Hello everybody, today I'm gonna show you a practical session to calculate sample size in R. Actually, you can calculate sample size in different ways using the sample size calculation formula from textbooks or from internet, or we can use softwares, softwares like GPower, Starter, and R software. I prefer R software for this session because R is free, available internet and easily downloaded and installed along with its plugin Rstudio. Besides, I prefer Rstudio or R for calculation of sample size, especially if you don't find the sample size calculation the fixed estimates, because some studies they not report the fixed estimate properly, or your study might be first ever study to be conducted. So the only option you have might be conducting a pilot study to have a field size for calculation of sample size. But sometimes this might not be feasible, particularly in randomized controlled trials. You study to collect data with pilot study may take weeks, even months. So it's not feasible to wait to have sample size calculated for this much of time. So the better option is to find the assumption based on prior knowledge on your field of study, particularly for that type of study, or you can meet the assumptions, the Cohen's assumption, which is developed by a known American statistician, Cohen, and named by his name the Cohen's T for test, Cohen's H for proportions, and eta for ANOVA, and there are also other assumptions for regression, cascade, and so on. So these assumptions, the Cohen's assumptions, are built in R. So we can proceed by installing R and Rstudio. So it is very easy to install and use R and Rstudio because it is free and available on the internet. So this is my Rstudio having 4 panels. This is the first panel on the right side on the upper right side. This is a panel for installing package, and on the left right side is the console, which displays installed package, and even we can run packages even on the console. On the left side, or the upper left side, currently it is empty. The environment is empty. We call it the environment panel. This is the variable view. When you import variables, the parameters will be displayed here. On the left side, here it is another panel which contains the file, the plot in the graph, the package, and help and other documentations will be displayed in here. So to start with, you need to have the package installed in R. So let's install the package. Install.package, and be in mind that the package should be in quotation. So power is the package to calculate the sample size in power. So to run the package, we have two options. Either you highlight or keep the cursor in front of the command line and run, or you may use Alt and Enter. So let me proceed with this one. Run. Now the package is installing. You can install as much as you can package, as many as packages, because this package will not be stored in your computer rather than stay on the server, so don't care about the size of the package one computer install. So the other thing that should be in mind is the attaching the label, the command. In other software like Starter, you don't need to attach the package. Once installed, you use it right away. But in R, you use to attach in the library as well as download. Let's see, for example, let's say uh, library, and the package is power. So run the package. Now this package is in our library, so we can use the package calculation. As I told you before, we have a number of formulas for calculation sample size based on your outcome index. It can be t-test, having different types of t-test, independent test, predicting one sample test. It can be for proportion, linear regression, classical test. So you don't need to remember all these steps. Rather, you can find them in in one location by doing the following. So you can write half and then the command power and hitting run. You know why? It says no documentation for power in space package and library. Go try power. I did this intentionally because I want you to see how R cannot do the business if you are not attaching the command. So the command is not attached. So you have to attach the command. You have error. Now you will find it the documentation is help. Is the documentation you can download it, not this one if you like. So go to index and you'll have dozen of sample size calculation commands. And so let's see, for example, this one, sample size calculation for single proportion. So here is the formula or function employed in R to calculate the sample size for single proportion. So what you have to do is you have to paste this one and then organize based on your outcome filters. Now I want to calculate the sample size, not the power. So let me take the 54.8 and I'll keep it n null because it is the one to be calculated. But I have to know the correct age. Where did I get this one? We have two options. One, from previous study, we have to calculate the age using the proportion. If you don't have study, it's reporting this kind of estimate, that is the proportion. So we can use the coins assumption. So coin determined coin's age, that is it exercise for proportion as small, medium, and large, which points 2, 0.5, and 0.8 difference from the sum and the population parameter. So for example, you can take a small difference, which is 0.2, and then we have to decide your hypothesis. We can decide the hypothesis. We have to do this combine command, the combine function. So we'll proceed with two-sided, with no difference between proportion. So let's run, and as you can see, H. So the sample size is approximately 200, having the power of 80 and coincidence of 0.2. Let's try another. For example, for two proportion having the same the same sample size, this one, power to be test. So you calculate this and then take this one to calculate the two proportion formula. So we can write this one on the command line, and this time also we'll take pointer 2 because we don't have any information about the fixed size from previous study. So I calculate sample size by taking the power of 0.8, and my hypothesis is two tail. I'll remove this combine function, and then it's this one. So now the sample size is approximately 400, that means 200 for each, because they are equal with two-tail test. Another example, let's see, for example, for t-test, independent sample t-test, having the same sample size. That is treatment and intervention. They have the same sample size. So this one is the t-test command. So this is we have to the coins assumption. This time, if you have mean standard deviation from previous studies, having two groups, for example, male, female, or intervention, control. Yeah, this kind of mean and standard deviation. And if your primary outcome is on these issues, so you can calculate the D by using the mean 1 minus mean 2 over the pooled standard deviation. Actually, I'll put this one in the description box, how this phase size is calculated if you don't know. Along with the link and other subscribe, I'll keep them. Don't worry about that. So this time, let's say for example, 0.3 in the small difference in case of coins T. The power is 0.8. And what type of t-test it is? It is independent sample t-test. We have two groups which are not dependent. And the hypothesis, a two-tailed hypothesis. So I'll keep this one and I'll remove the command function, just like this. So I'll run. So this time, two sample t-test power calculation. So the sample size is approximately 180 with a power of 80% and the coins T of 0.3. Now let's see how the power changes with changing coins T. And let's calculate the power. So let's start with this one. For example, you write now. This case is deep, so you don't be messed up with your spelling. You have to write properly the spelling in the comma. So the sample size, let's say 200, this one, and we'll keep them. We'll keep them as default, the rest of the parameters. So let's say, so the power says the power is 1. So let's make it is 2000. Let's say with 200. So it is 0.84. So you can calculate the sample size as much as you can based on your primary outcomes. So as a rule of thumb, you might have a number of objectives, and you have to calculate for each objectives. So the the objective might be some may be the mean with mean, but they may report with mean, some may be with a statistics and or some may be with proportion. So we have to calculate for those and take even with regression in regression coefficient or in terms of threshold. So we can calculate with those statistics and then take the sample size with the largest value. This is all about the how to calculate the sample size. If you have any question, any comment, you can write on the comment line and I'll respond as much as I can. So if you like this video, please like, share and comment. Thank you very much.